Hello, Calculus 3. This is section 4.8, Lagrange multipliers. Now notice I might have pronounced that word a little different than you might have expected. So that's because it is the last name of a Frenchman. And so we pronounce it the same way he would have pronounced his name, Lagrange. This can be difficult for people like me, who I grew up in a small town, Wisconsin, and my elementary school was called LaGrange Elementary School. But really, it should have been Lagrange Elementary School. So I think one of the best ways to deal with this is if where you're watching right now, in your most strongest French accent, as loud as you can, you go Lagrange. And that way your roommates will know that you're very cool and definitely not crazy. Okay, but first, let's begin. Hear, O Israel, the Lord our God, the Lord is one. You shall love the Lord your God with all your heart, with all your soul, with all your mind, and with all your strength. The second is this: love your neighbor as yourself. There is no commandment greater than these. Okay, heart's full and mind's ready. Let's begin. So now I'm going to set up the theorem, and then I'm going to talk about the problem-solving strategy, and then the rest of the lecture is going to be examples. So if you don't understand exactly what I'm saying right now, try to remember as much of this as you can, and this will help you as you do the examples to see the patterns better. So I've got two functions, f and g. And so f is going to be the function that I want to maximize or minimize. So I want to max or minimize that function. G is going to be my constraint function. So sometimes one of the examples I'll actually have two constraint functions. So I want to maximize or minimize a function. I'm calling that f, subject to some constraint function, which is g. So I want to turn that constraint into everything on one side of the equation, zero on the other. And so then my function is going to have a local extrema at a point AB. And then as long as the gradient of g is not equal to zero, this thing will work. Then there's a number. This is called, this is a Greek letter, lambda, pronounced like the baby sheep, and then duh. So like duh, baby sheep, lambda. And so that lambda is called a Lagrange multiplier. And so we use the gradient of f is equal to a constant times the gradient of g. Okay, so let's now talk about the problem-solving strategy. So f is going to be the objective function. G is a constraint function. So you have to kind of ask ourselves, are we maximizing or minimizing? And then we're going to set up a system of equations. We have one equation where g of a b equals 0, like it's on the constraint. This constraint is true. And then the gradient of f is equal to lambda times the gradient of g. So we want to solve for a and b. We sometimes solve for lambda to get at a and b, but sometimes we don't need to solve for lambda. There may be multiple solutions. So we're really turning a calculus problem into an algebra problem. So the largest function is going to be the maximum, the smallest one will be the minimum. So this only works when they are differentiable. So check endpoints. Sometimes your function's not differentiable at the endpoints. So always check your endpoints to be safe. Okay, so that kind of goes through the main things to look for as we do these examples.